Hello everyone. Today we are going to start our next unit, Unit 4, which is graph theory. Now let's see what is meant by the graph. Graphs are discrete structures consisting of the vertices and the edges that connect these vertices. The graph models are used to solve the problems in a variety of the areas. For example, using the graph models, it can be determined that whether it is possible to walk down all the streets in a city without going down a street twice. Means by using this graph model, we can determine our destination in the streets in a city without going down into that particular street twice. The graph model is useful to find the number of the colors needed to color the regions of a map. We can determine whether two computers are connected by a communication link using the graph models of a computer networks. Similarly, it can be used to solve the problems such as finding the shortest path between the two cities in a transportation network. Now let's see what is the definition of that graph. A graph G is equal to VE consists of V is nothing but a non-empty set of the vertices or the nodes, and E stands for a set of the edges. Each edge has either one or the two vertices associated with it, called its endpoints. An edge is said to connect its endpoints. This edge is nothing but its endpoints of the two vertices. See here one example of the graph. According to our definition, V means set of the vertices. So in case of this example, A, B, C, D, these are all vertices of this graph. And for set of the edges, in this case or in this example, A, B, B, C, C, D and A, D. All these are edges of this graph. Now let's see what is the basic terminology. Means there are the basic terms which are useful in this graph theory. Before going into detail of the graph, you have to know or you have to understand first what are the basic terms of regarding the graph theory. First one is directed graph. Definition: a directed graph or the digraph means directed graph also called as a digraph. The digraph VE consists of a non-empty set of the vertices V and a set of directed edges. See here, the set of directed edges. An edge which is associated with an ordered pair of the vertices is called a directed edge. So this is the definition of the directed edge. Means that edge which is associated with an ordered pair of the vertices, that edge is called as a directed edge. In other words, we can say that a graph in which every edge is directed is called a digraph or directed graph. This is very simple definition of the directed graph. Means in that directed graph, each and every edge is directed. Then this directed edge associated with the ordered pair UV is said to start at U and end at V. Understood? This is the directed edge. An edge is said to be incident. See here the new term, incident. An edge is said to be the incident with the vertices it joins. For example, the edge AB. In this edge AB is incident with the vertices A and D. In other words, it can be said that the edge AB is incident from A and it is incident into B. You can take another example, suppose edge CD. Then in that edge CD, that edge is incident from C and is incident into D. The vertex A, in the case of the edge AB, the vertex A is called as a initial vertex and vertex B is called as a terminal vertex of the edge AB. A directed graph may contain loops. Okay, it may contain the loops. An edge that is incident from and incident into the same vertex is called a loop. Means which edge, which is that edge incident from and incident into the same vertex, that edge is called as a loop. The two vertices are said to be the adjacent if they are joined by an edge. For example, in the edge AB, the vertex A is said to be adjacent to the vertex B, and the vertex B is said to be adjacent from the vertex A. In case of the, you can take another example, the edge CD. The vertex C is said to be adjacent to the vertex D, and the vertex D is said to be adjacent from the vertex C. A vertex is said to be an isolated vertex if there is no edge incident with it. That vertex is called as an isolated vertex because there is no edge connected with that vertex. That's why that vertex is called as an isolated vertex. See here one example of the directed graph. What is our definition of the directed graph? In the directed graph, each and every edge is directed. That's why that graph is called as a directed graph. So in this graph, AB is directed, then BA, then DA. So each and every edge from B to D. So in this graph, each and every edge is directed. That's why it is called as a directed graph. See here, there is a vertex C, which is isolated vertex. Why it is called as isolated? Because there is no connection from this vertex to another vertex. Means there is no edge between this vertex to another vertex. That's why this vertex is called as a isolated vertex. There is another example of this directed graph. See here, in this graph also each and every edge is directed. Next, an undirected graph. An undirected graph VE consists of a non-empty set of vertices V and a set of undirected edges. So by this definition you can understand this undirected graph is totally opposite of the directed graph. In the directed graph, the set of directed edges, but in undirected graph, the set of undirected edges. Similarly, an edge which is associated with an unordered pair of vertices is called an undirected edge. Then in case of the directed edge, an edge which is associated with an ordered pair of vertices. So see here, there is a difference between the undirected and directed. In directed, ordered pair, but in undirected there is unordered pair. Next, a graph in which every edge is undirected is called an undirected graph. In case of directed, a graph in which every edge is directed is called a directed graph. So there is a difference between the directed and undirected graph. See here one example of the undirected graph. A, B, C, D, these are the vertices. There are edges also, A, B, B, C, A, D. So in this graph, there is no direction. Okay, so this edge and every edge is not directed, means undirected. That's why this graph is called as a undirected graph. Next, simple graph. A graph in which each edge connects two different vertices and where no two edges connect the same pair of the vertices is called a simple graph. Next, a graph that has no self loops or the parallel edges is known as a simple graph. See here again, what is the definition of the simple graph? A graph in which each edge connects two different vertices, means not same vertices. Okay, there must be two different vertices and no two edges connect the same pair of the vertices. Here also no two edges connect the same pair of vertices, must be different pair of the vertices. Then and then only we can say that that graph is a simple graph, and that simple graph must not contain the self loops or the parallel edges. Okay, so see here one example of the simple graph. here there are the two different vertices for the edge AB. Okay, AB, in this edge AB there are the two different vertices. Same, no two edges connect the same pair of the vertices, and that graph can also contain the self loops, must not contain the self loops and the parallel edges. So here there are the no self loops and no parallel edges. Then we can say that this graph is a simple graph. Next, an asymmetric digraph. Digraphs having only one directed edge between each pair of the vertices but can have the self loops are called the asymmetric digraph. An asymmetric digraph, in this digraphs having only one directed edge between each pair of the vertices. So in this example AC, there is a suppose there are the two vertices A and C. In this vertices there is only one directed edge. There is no another edge between A and C vertices, and but it can have the self loops. So in this example B have the self loops. So these conditions are satisfied. That's why it is called as a asymmetric digraph. It's only one directed edge between each pair of vertices. There is it is the condition for the asymmetric digraph. Next, a symmetric digraph. Digraphs in which for each edge xy there is also an edge yx are known as symmetric digraphs. Means it is totally opposite of the asymmetric digraph. In the asymmetric, only one directed edge between each pair of the vertices, but in this each edge for each edge xy there is also an edge yx. So this is condition for the symmetric digraph. So in this example, see here, there is an edge from x to y and there is also edge from y to x. Similarly, from x to z and z to x, z to y and y to z. So condition is satisfied. So we can say that this graph is called as a symmetric digraph. Next graph are the isomorphic graphs. Two graphs are said to be isomorphic if there is a one-to-one correspondence between their vertices and between their edges such that incidences are presumed. So what is the condition for the isomorphic graph? One-to-one correspondence is must between their vertices and between their edges also. In other words, we can say that there is an edge between the two vertices in one graph if and only if there is a corresponding edge between the corresponding vertices in other graph. So these if condition is satisfied, then that two graphs are called as a isomorphic graph. What is the condition? One-to-one correspondence is must, means edge between two vertices in one graph, then there must be a corresponding edge between the corresponding vertices in other graphs. So let's check here in the example. So in the isomorphic graphs there are the two types, undirected isomorphic graphs and directed isomorphic graphs. So by the name itself you can understand what are the isomorphic undirected graphs. Those isomorphic graphs does not contain any directed edges, that graphs are called as a isomorphic undirected graphs. See here in this example, in the first graph AB edge is there. So this corresponding edge, there is in the second graph there is also AB edge from this there is a corresponding edge AB in other graph also. Similarly, BC edge is there in the first graph, so corresponding edge BC in the second graph also, means there is a one-to-one correspondence between the first graph and the second graph. So here the condition is satisfied. So we can call both these graphs are the isomorphic graphs but undirected graphs because there is no direction or no directed edges. Similarly, these are isomorphic graphs but directed graphs because each and every edge is directed. That's why we can call as a isomorphic directed graphs. Why this called as isomorphic graphs? Because each and every edge, corresponding edge, so this edge is also present in other graph also. In the first graph, AE edge is there, the corresponding edge or corresponding vertices A dash and E dash are there, and there is edge, their edge is also present in other graph. Similarly, HE, so there is present the HE edge also, means each and every edge in the first graph there is a corresponding edge in other graph and corresponding vertices also. So condition is satisfied of the isomorphic graph, so we can say that these are the isomorphic directed graphs. Next, subgraph. What is the definition of the subgraph? Suppose there is a graph G, V and E. V stands for the vertices and E stands for the set of the edges. Then a graph G dash is equal to VE is said to be, or V dash and E dash is said to be a subgraph of G if E dash edges is a subset of the V dash or vertices such that the edges in E dash are incident only with the vertices in V dash. So this is the definition of the subgraph. Subgraph means this is a subset of this graph G, which is nothing but a subset of this graph G, means E dash and V dash. E dash is subset of the E and V dash is subset of this graph V. Then a subgraph of G is said to be a spanning subgraph if it contains all the vertices of G. This subgraph is also called as a spanning subgraph when if it contains all the vertices of G. Then the another term is there, the complement of a subgraph G dash. The complement of subgraph G dash is equal to V dash E dash with respect to the graph G is another subgraph G double dash is equal to V double dash and E double dash such that E dash is equal to E minus E dash, means E relative complement E dash, and V double dash contains only the vertices with which the edges in E double dash are incident. So what does it mean? The complement means those edges present which are those edges are considered which are included in subgraph G. Means if the edges included in subgraph G, then that edge does not present in the complement of a subgraph, because the condition is there E minus E dash and V dash contains only the vertices with which the edges in the E double dash are incident. See here, by looking at this graphs you can understand what does it mean. This is a graph, first this is a graph G which is represented in figure A. Then this is B. In the graph B or in the graph G dash means subgraph. Subgraph, what is the definition of the subgraph? It is a subset of V dash it is subset of V and E dash is subset of E such that edges in E dash are incident only with the vertices in V dash. That's why this is the example of the subgraph G which is represented by figure B. Then another term which is represented in graph C or in figure C, that is complement of the subgraph which is represented by J double dash. So what is this complement of the subgraph? The complement of the subgraph J double dash means those edges present in this complement of this J double dash which are not included in this graph G. Understood? Means if there is, suppose for example, suppose there is edge is present BG which is present in the subgraph G dash, but in the complement of this subgraph it is not present. Same, if it is from C to D, there is no edges present in the subgraph, but there is edge is present in the complement of the subgraph. Means totally opposite of the subgraph, it is called as a complement of the subgraph G dash. Those edges are present in the subgraph, those edges are not present in the complement of the subgraph. So here these are the examples of the subgraph, complement of the subgraph. Okay, so next terms we will see in the next lecture. Okay, thank you.